Hi, everyone. My name is Magenta Strongheart, and I'm Head of Design and Partnerships at Supply Frame's Design Lab. Thank you so much for joining us for our first Dream Team presentation of 2021. We are so excited to dive into EJA's open source hardware solution for ghost gear in our oceans. Before we get too far into that, I'm just going to give you a little more info on the Hackaday Prize and the Dream Team initiative. This is our 8th year of the Hackaday Prize, and we are so excited to be able to support open source hardware projects through this amazing contest each year. We are currently in challenge 3, so that means there's still three challenges left to participate. So all of our engineers, innovators, and hackers out there, please look into the Hackaday Prize at prize.supplyframe.com, or you can check out Hackaday Prize at hackaday.io to learn more about the upcoming challenges. Plenty of opportunities to win big. There is a $25,000 grand prize award on the line, so be sure to check that out. Now, for our event today, we want to get right into Dream Team EJA's project. They were actually one of our first Dream Teams last year, and we're excited to be able to invite them back to further develop their solution. We saw so much potential in it. We wanted to keep the impact going. So today we're going to have a brief presentation to get us all up to speed to what EJA has been working on. And then we'll have some time for feedback from our amazing special guests we have here today, our Dream Team mentor, Clarissa Redwine, who's also an NYU fellow, and Dr. Triple from Canada's Department of Fisheries and Oceans. Thank you so much to you both for being here, and we're excited for the discussion in today's presentation later on. And last but not least, we will have a few minutes at the end for questions from our audience, so be sure to comment. If you are joining us live, we would love to hear from you. Any questions or feedback you have for our team, we would love to incorporate that into the discussion as well. I'm now going to pass it off to Giovanni Salinas, Design Lab's product development engineer, to introduce our team and tell us a little bit more about today's presentation.
Thank you, Magenta, and hello, everyone. Thank you so much to our guests for being here today. So we're here today for the preliminary presentation of Dream Team EJA. The team includes Erin in Canada, Toby in Nigeria, and Leonardo in Venezuela. Hello, team, and thank you again. Thank you for your dedication. So Team EJA has been developing this project since last year to help fishers reduce the amount of ghost gear in the seas. The team, today we're going to learn about the improvements that the team has made to the original version and improvements and enhancements. So I am very excited to pass the microphone to the team. The floor is yours, Team EJA.
Perfect. So I'm just going to, reiterate the problem again. We are Team EJA. We just working to solve the ghost gear problem, and the soak time. The next slide, suppose. Okay, cool. And that's the how can we solve the soak time that the the gear is left unattended to. And how can we make it more intelligent and have some smart devices connected to it? So it's still the same problem that we've talked about before. And now we're still, working more on the same problem to make sure that our intelligent buoy system is sustainable and cheap enough for people to use. I'll pass you on to Leo.
So for project objectives, to make it really straightforward for this revision, it's basically making version 2, so that way we can give it to a fisher to beta test. This is basically the golden vision that we are following to guide the decisions we are making for this iteration. And then goal number 2 is to make it reliable. Now I'll pass it on to Leo to cover more of the development side.
Now, for a list of more specific objectives that we're focusing on while we are developing, we have create a robust and user-friendly release mechanism. It is not only important that it's user-friendly, because we don't want the device to reduce the productiveness of the users, that be the fishers or the researchers, if they decide to use the mechanism. Now, reduce the price. Right now, from our previous design, we are looking into from $530 to $600 device, including the release mechanism, the buoys, and the onboard gateway. Those are several designs that we'll be covering in this presentation in the future. But one of the goals, and depending on the feedback that we got last time, is to reduce the price. That is very important. Reduce the size of the electronic design. We are creating a more robust mechanical design so that it is helpful if the electronic design is smaller. Include some features. Also, we will get back into this in the future slides, and develop a mobile user interface that is easy to use and is convenient for the users. Next one, please. Now, the device overview. How we're going to achieve our software and hardware. And next one. Okay, this is a brief description of the certain terminology that we are going to be using during this presentation, and also to cover the devices that we have been developing and that we are currently that will be enhancing. We have in the images on the left, we have the onboard gateway. This is a device that the user has with itself that provides direct communication with the buoys that are on the water. So this is a device that is on board, that is in the ship, and you are connecting directly to it with your phone. On the right, we have the buoy and the base. The buoy, that we expand more later, contains the electronics and all the sensors that provide the intelligence side. And the base is all the structure related to the pop-up mechanism or related to the ropeless system that we are using. Next one, please.
So I wanted to follow the journey of how you can actually use this device together with the mobile application. I'm going to start with the first, I will go very fast. So the first thing we have to do when you access, let's say you have the buoy and the gateway, and you're about to deploy it and ready to go into the real fishing process. The first thing on the UI interface is that you want to connect to the gateway Wi-Fi. So we've got the onboard gateway, we've got the buoy. So the onboard gateway has its own Wi-Fi. On the app, you can directly connect to the gateway through the Wi-Fi. So that means you would see, like the second picture shows that it's connected. So if it's not connected, you will see another message that shows it's not connected. That means your device is not connected to the gateway, because it's more like, before you can access the buoy, you need to connect to the onboard gateway first. And then we created a little bit of menu that you can easily navigate around the whole application. So either you want to ping the gateway, you want to test the buoy. I'm still going to show each of these gateway pinging, deploy time, and the other information. So don't forget, you connect to the Wi-Fi first, and it shows connected. And then when you ping the gateway, this is the information you get. You get this specific information. Like we just name it EJA 001. We can change it, but this is just what we're working with right now. And this information is pulled from the gateway. We didn't put it ourselves. So the onboard gateway will get this data across to the user so that you know that you're actually connected to the onboard gateway. And before you now, go to the process of being sure that the onboard gateway is also connected to the buoy. And you can see the battery percentage, the signal strength of the onboard gateway to be sure that there is a very good signal strength. Next slide, please. So, and then you want to ping the buoy to be sure gateway is connected, buoy is connected. What kind of information do you want to get from the buoy? You want to know the buoy ID and the battery percentage, because it's going to be far away from where the gateway is, and you're ready to deploy it. So that means all this information and parameters must be standard. The frequency there is the LoRa frequency, because we're using the LoRa technology, and there is always need to assign a frequency based on location. This frequency you're seeing here, it's for Europe. The one for America is different. The one for Asia is also different. And we created another GUI for test. Before you deploy inside the water, you want to be sure that the motor actually works. You click on the first test, it spin the motor. You click on another speed test, it increased the speed of the motor to 5 times. And then there's an accelerometer we're trying to add here that we're still trying to figure out if we should use the switch to turn it on or off. And then you want to set your time. How is it for 7 a.m. in the morning? You want to deploy your buoy system. you need to set all this information before you go into the fishing environment, like ready to deploy the buoy. And then when you set the time, there's another part that shows the countdown. So you'll be notified and say 10 minutes remaining to the deployment. It's just like you want to launch a rocket. This information helps you keep in track of when the buoy will be deployed. Next slide, please. Before you go, before the next slide, there is a refresh button that was added to this so that you can know the updated time. That means if it's 5 minutes remaining. On a good day, the app supposed to do it on its own, but we see if it could not work like refreshing on its own from the back end, you can always click on this icon and refresh the time yourself. Next slide, please. While you're following through the journey, we want to get some information from the device, like the GPS data. We want to make sure that you still sync with the buoy. If you click on this sync, you can get the updated GPS location. We can visually see it from the map. And then you can track it, meaning you can track it from where you are, see it on Google Map, and then go to where the buoy is. And we're also planning on adding the geofencing kind of mechanism, like application. So you don't want your buoy to, pass through this perimeter. So you can create some sort of geofence, and you get notified when the buoy passes through those perimeter. This other slide, this other UI, it's also very important because we're having a thought of, let's say the fishermen want to have like 50 buoy system. So we want to create a platform where they can register buoy. And don't forget, we are using Gateway. The Gateway can accommodate about 1,000, depending on the kind of capability. But this part gives you access to register new buoy. You just click on registration, then you update the location. You get a time. If it's connected, you see the information that it's connected, and it will kind of assign. So there's another picture here that is not added because of time. So you have to enter the buoy ID. So don't forget, we've got an ID for each of the buoy. So when you enter the buoy ID from the back end, we can understand that you just assign a buoy to your gateway, meaning you can assign like 5, 6, 7, 8, 9, 10 buoy. And the last one is more of, you want to reach out to us. We just added that slide for support. Next slide, please. And I think it's Aaron. Oh, Leo, yeah.
Right. Now we're going to be discussing the features that we have in the device, the devices we're calling the buoy and the onboard gateway, and how the current designs that we're working on right now compared to the other ones that we made last year. What are the design choices and why we're moving in that direction? First of all, let's briefly see the features that we have. In all the three, in last year, we made 2 designs for the buoy. So those are buoy A and B. And now we're working on a new one that is the new design in the table. So the 3 of them have GPS for location, have LoRa for communication, have the same ESP32, and have support for a servo motor that we are using on a release mechanism, and have a real-time clock to store the date and to manage more internal processing. Now, what is the difference between them? The main difference between the devices that we made last year, buoy A and B, is that one of them has 4G communication because we were exploring the idea, and the other one, that is the B, doesn't. And now, how we are approaching this new design. In this new design, the main components that are the ones that I mentioned before, we are maintaining them, which is the GPS, the LoRa, the microcontroller, and the servo. But we also are adding new features, which is a battery charger for the new design, an accelerometer. The accelerometer is going to be used to have some feedback on orientation during deployment to make some small readjustments, and voltage protections, which is for one side, it's very useful to have like reverse voltage protections, maximum voltage, transient voltage for approval in order to be able to sell the device. And also, and finally, what is very important is the price. We are comparing buoy A. Buoy A, that was one of the devices that we were making, was $131. Buoy B was $200, and now we are making a new design that we are estimating that will be $70 for the manufacturing process. We will discuss more later on how we are going to reduce the price. Next one, please. Okay, now for the onboard gateway, the other device, we have how the new design compares to the previous one. Well, basically, we are maintaining the features, maintaining LoRa, maintaining the ESP32, maintaining the battery charging, and we are adding a couple of features. We are adding a real-time clock, and we are adding voltage protections. Also, the price also sees a dramatical, well, it also sees a decrease since it's one of our objectives. From $84 to what we are expecting to be $50. Now, next one, please. We're going to discuss briefly on how our previous designs were and how we're going to be able to achieve this price, how be able to decrease the price. Now, in our previous design, just looking at the buoy, this is one of the PCBs of the buoy. We can see front and back the design, and it is possible to see that we have a main PCB that has attached to them other boards. The other boards are development boards that we are using, that we're buying. So these are solutions that we are getting out of the box. Our designs are joining all of them and implementing all of them together, and that this is very beneficial for rapid development. Now, next one, please. Now, for the onboard gateway, we have now the same way. We have the ESP32, we have LED, we have the LoRa, and we have the battery charging features that we mentioned before. And we can also see that in the PCB, we have other development boards mounted on top of them, connecting them. And that was basically the idea behind our last prototype. Next one. Okay, now, so what we're going to do in this cycle of development and during this experience is to move from the development boards that we were using, that we saw were mounted on top of the PCBs. That will be, for example, in this case, we're looking at left, we're using the ESP32 dev kit 32D. And now what we want to do is to not use the development board, but maintain the main component that we're looking to the right, the ESP32 room, and create our own adapting circuit. And this helps to reduce the price, but it also gives you more uncertainty, because the benefit of using out-of-the-box solutions is that you decrease development time, but you increase the cost and also increase the size, because you're adapting another design and you have a lower range to change the size. Next one, please. So what we're doing right now is that, notice that I mentioned that we're exploring using the main components of those development boards, like the microcontroller that I mentioned before. So what we're doing right now is that we're creating our own custom circuits to explore sensors or to explore transceivers that we want to use. And we are creating our own boards to see if we can test them before we implement everything together in a concise design. Right now, we can see in the image to the left, we are testing, this is a PCB that we made where we are testing 2 GPS. To the right, this is a PCB that we made to test the LoRa communication, the sensor the transceiver that we're using. Next one, please. Now I'll leave you with Erin.
Okay, so for the design, what we are focusing on this time is making it easier to assemble the buoy internals, meaning that it'll be faster once everyone gets the pieces to put it together. We want to adapt it to different depths. So it's on a scale of 10. So the first one being 10 fathoms, then 100 fathoms, all the way up to 1,000 fathoms would be one of our big stretch goals. Reaching 1,000 fathoms means that we could also help with sablefish fishing. We're going to update the base. However, after a bit of a research and experimentation, we're still going to go with the spool method rather than the rope coil method. For the release mechanism, we're keeping with the wiper mechanism. For now, we're sticking with the Nalgene bottle. It will allow us to do some more accessible experiments and make it accessible to citizen scientists. That being said, it's still the form factor of a cylinder, which means that it's open to adaptation to carbon fiber tubes, so that way we can reach those depths that we want to achieve. Now we're going to talk about testing. So testing being the functionality and testing with fishers. All right, so, oh, sorry about that. A slide advanced. Okay, so here's our current plan for testing, but what we really need is a lot of feedback on this to make sure we're going about it in a logical fashion. So we're going to do functionality testing at shallow depths just to start. And we really want to sprint towards getting feedback from beta tester fishers. We have one lined up, hopefully, and additional beta test fishers would be helpful as well. What we need to know is what will they feel comfortable with testing, since we do know that their time and resources is extremely valuable. The factors or the criteria that we are going for the most is number one, reliability, then number two, cost, as you have seen through this presentation. Following that, it would be functions in all conditions, the reset ease and time, and making it durable. Some things that were considered but did not make the top 5 were minimal drifting, that is under the water, and then travel to the surface time. Some additional testing that may help could be a hydrostatic pressure testing, which is located at Memorial University, the cold water deep ocean research facility, as well as hearing more about the ropeless gear framework that's being developed by the Canadian Wildlife Federation. So that leaves us with a few questions. So for the functionality testing side, we're looking at testing it in Lake Ontario, but of course, sometimes the conditions are very calm. So we're wondering, what are ways that we could simulate what these real world conditions that fishers face? We may need some assistance for testing deeper depths. We have no idea if it's as simple as this, but for example, could the Coast Guard help looking at 3 to 6 total hours over 2 days, basically go to a spot, put the gear down, and then come back, and then the next day do the same thing but retrieve the gear? Not sure if it's that simple. So what would be needed to know beforehand would be great. Came up with this observation that there are flume tanks, but are these types of simulations actually helpful? This would be good to know. Next up is impact. So how might we achieve the greatest impact with these devices? I mean, we're making it open source and we're doing so for a reason. As you saw with our team, we're spread out all over the world and we want to make it reach all over the world. So how about this? Let's make a big splash and use Kickstarter to deploy to early adopter fishers. Now, that being said, do realize that that is quite a bold move. And so we're looking for feedback and a discussion on how might we do this in a way that sets the expectations of this highly experimental nature of the project and product. Then also crowdsource the performance of the device across a variety of use cases. For example, we may see beyond trap and pot fishers to net type of fishers. We may see citizen scientists who want to do benthic research, or we may even see academic researchers as well who also want to do benthic research. That being said, how do we be respectful of fishers? Because they've been doing this for so long, it's such a hard job, and they put a lot of time and effort into feeding the majority of the world with this source of protein. So with that, we hope that you're excited with the development we have been doing, and we are open to your input and advice to this. Thank you.
Thank you so much to Team EJA for that comprehensive presentation. I think that got everyone up to speed with all the work you guys have been doing, not only last year in the first round of Dream Team prototyping, but also since then. You guys have been actively working on this project throughout this time. So we're super excited to hear from our special guests and also the community on what questions or feedback they may have. I think some of those questions you outlined already, Erin, are a great start. So I'll pass it off to our guests now.
I'm happy to dive in and talk first a bit about more of the community and Kickstarter side of this rollout potentially. First I wanted to start with how you all are focused on open source. Have you engaged the open source community already and sort of made strides with that community? Because that would be a really compelling part of the story if you were to take it to Kickstarter.
Toby, would you like to answer that?
Yeah, I didn't give them the whole, because I'm part of the board member for Open Source Hardware Association. So, but I didn't give them the whole story of what we are building about the, Kickstarter, but they know about it as being open source because it's available online. Maybe the next meeting I could, chip it in and just get ideas from them as well. So, yeah.
Awesome. Yeah, that sounds really exciting. I know all of you are perfectly poised to sort of encourage participation from that community. And if you were to sort of show how building something open source and incorporating the community's input has magnified the impact and the efficiency of the hardware, all of those sort of like components of the importance of building an open source product would be incredibly important for the narrative of a Kickstarter campaign. And you're not really speaking to the fishermen that you're talking to whenever you're launching a Kickstarter campaign. You're more talking to the community that is interested in building open source hardware and sustainable solutions. And yeah, so building out that narrative would be really important. Yeah, and I'll let Ed jump in if you'd like to.
You're asking me to jump in? I wasn't sure. Yeah.
Yes, go for it.
Okay.
Yeah.
Yeah. No, congratulations, group, on what you've achieved so far. And I had a few questions on exactly what I'm seeing. So, are we looking at a time release, or are we looking at an acoustic signal with hydrophone release? It looks like it's a time release.
Yeah.
Yes. Right now we're looking at a time release. We have been considering, of course, like acoustic signaling, but right now we don't have it in the primary design. We have it as a future idea to implement, because there is something that we have to know more and have more knowledge in order to implement it correctly and integrate it to the design.
Okay, good. And for the time release, so just so I can be walked through it a little bit slower. So the device is set, the location is then marked electronically, and basically the gear is going underwater, but it could also drift with currents and so on based on depth. Basically, you know the location at the surface. You don't know the location once it goes below the water. It's just, I want to verify that too. There's a lot of features there, and I just wanted to be sure of all the limitations.
Yes, that's correct. That's why we were, but everything you say is correct. We included LoRa in between the design to be able to locate the buoy if it moves from the initial location when it's been deployed. But it's correct that without a means of acoustic signaling or communication, we will have the new position of the buoy once it gets to the surface, and we can have some type of communication. That granted, LoRa gives you a lot of range to move. It has a lot. Yeah, you can communicate to it from a longer distance, but in either way, you will have to wait until it's on the surface.
Okay, good. And then the surface buoy, the Nalgene bottle, whatever you use, the flotation is enough to elevate the rope of say a 3/8 inch diameter rope. What diameter rope have you adjusted your model for with the amount of flotation, and if it's all floating rope or partially sinking rope? There's some, I guess some adjustment would have to be made for the amount of flotation you're using, and then the time it can stay on the surface as well, with the amount of the scope of the rope compared to the water depth. Is it 2 to 1? So all those factors, have you started to think about that part yet, or just that's the next steps?
So that calculation is actually next on the list for this weekend and next week. So yeah, that's a good thing to keep in mind.
Yeah. From the things that are out there already that are a little bit like this, but not exactly like this, you've heard of the galvanized time release, where they have a small piece of zinc, for example, and they can estimate the time for the zinc to corrode in salt water, and based on the thickness of that, it then also results in the release of a submerged hard plastic buoy. Important, as you know, to use hard plastic so it doesn't collapse at depth, at pressure. And some of the one company is called Long Soaker. They work out of, I believe, Seattle, and we've been working towards releasing fresh bait within a trap. So fishers sometimes set traps for a certain amount of time and the bait loses its freshness, so their Long Soaker actually expands the time in which fresh bait is then released into the trap. So there is a galvanized time release, and I did speak to some people in Western Australia with rock lobster, and they've played with a time release in the past, so it may not be quite as fancy as yours. So I'm just wondering how you evolved to your level of time release, and whether it's cost effective, or is it maybe I'd like to hear a little bit more on how you ended up with that, with your approach to doing that.
Yeah, so how we ended up on the wiper style of release mechanism, well, we of course saw the galvanized time release, and a lot of the feedback we get is it's probably going to be a good idea to have that as well for a backup, just in case everything else doesn't work. But how we arrived at the wiper was starting first with the constraints of the cylinder that we were working with. So we were like, okay, how do we make movement that is coupled internally to externally, so that way everything is watertight. Based off of that, magnets rose to the top of the list to investigate, and that's how we arrived at that one. The fun part, though, is that there are so many different methods of ropeless gear. There's the propulsion method of lobster lift, which is fantastic. There's the rotating lock of a shord. And there's the sort of pyrotechnic method of Desert Star, where it's a burn wire release. So all of these different methods have different approaches and advantages.
You've done your research for sure on the different devices, and I think the appeal of your approach is it would be the time release is there. It's affordable. I think a lot of the other acoustic releases are what they call ropeless on command, or pop-up buoy. It basically controls exactly when they want it, but that's not going to be affordable for a lot of fisheries. And so having have an alternative. I'm thinking more internationally here in some areas which would be less stringent in their requirements for a ropeless. Some countries might require absolutely no rope in the water column until the command is sent, and that's why acoustic releases would favor those management systems. But if you're looking towards reducing the amount of vertical line in the water when you're not tending your gear, then the system that you're looking at definitely reduces that by maybe 90% or so, depending on a timing of visiting your gear and when you set it for. And so if you have, say, 100 traps to visit through the day and you preset your timing all 100 traps, say it's 10, I'm just theoretically saying X amount of minutes between each one as you set it. So you're expecting the revisit to your gear to be timed as close as to when that gear comes up. So there will be times when the gear is up and you're not there. And those are the times when it still is potentially can be picked up by a whale or any kind of passing vessel or whatever, which would contribute to ghost gear. So I see obviously your design is focused on doing both, reducing entanglement of large whales and also reducing the chance of lost gear by snags with other vessels or lost gear or so on. So I see from that perspective a lot of merit in your design, and I think your next steps are to start to play with the things that I talked about, and I'm sure thought about is getting it in the water and trying it and see how reliable it is, and then potentially looking at your markets internationally, which governments are more likely to adopt a time release versus acoustic release going forward, and to make sure that your product is the most likable and usable, and is judged against those that are currently out there with time releases. I think I'll swap for now.
Yeah, I actually have a related question. I'm kind of curious what your ideal plan for deployment or introduction into the market or the ecosystem. What does that look like? Are you trying to lead through sort of partnership with local governments, or are you hoping that the maker community will lead the charge? Like, what does that look like?
Well, it's a good question. So how exactly are we going to bring this to the world? We've seen a lot of methods from a lot of the other gear who do go that route of very formalized, follow every step, work together with the government, and then work together with fisheries. What we have not seen yet, and this is an opportunity that invites a variety of use cases and invites the open source community to participate, is casting a wide net through a crowdsourcing approach. So there's pros and cons to each approach, but there's this huge opportunity in the world if we do try the crowdsourcing approach and just getting it out into the hands of people all over the world. Maybe we'll see it in more places than just the coasts of Canada. Maybe we'll see it in so many locations in the world. It would be, maybe it could be faster too than going the traditional approach.
Interesting, yeah.
Another thing, another thing that I wanted to mention, following up what Erin was saying, is that we have had that inspiration since the beginning, and we have been designing since last year to have a product or a device that is easily adjustable and with very common and widely used components like the microcontroller and specifics, because it would have a wider appeal to be able for the maker community if you want to improve or if you're going to develop it more or use it for another application. So also connected to a question that we had before about the electronic release. That is one thing that also has an advantage, because having the electronic release makes it easily adjustable, and having easy to use components and an open source hardware and firmware makes it easier for you to also adjust it to your specific implementation. Maybe being only changing the timer, that also it's an adjustment, or also being connecting it to other hardware or an additional hardware that you have that you want to expand on and that you want to explore more capabilities.
Yeah, that's great. I definitely would suggest that as you're like pushing out into your beta testers and thinking about how to demonstrate how this hardware is going to work in the wild, if you are looking to harness, the creativity of the open source community, it's really important to show a kernel of what could be done with the hardware. I know you already know this, but it's sort of important to capture documentation of these things sort of working, so that you can paint a picture of how scaling the use of your solution could look, and sort of inspire people who are contributing to your crowdfunding campaign. But yeah.
I want to
Gio,
ask
did
you
you have
something, guys.
Oh,
Yeah,
there you go.
I have a
Psychic here.
quick question. I'm interested in your thought process about the rechargeable batteries. You initially had regular old-style batteries, and now the rechargeable that's more friendly with the environment, but at the same time cheaper. So how did all that happen? What are the advantages of it?
Well, yeah, like you mentioned, one of the main advantages is that, of course, it's cheaper in a longer use if you have an easier way to recharge it, so you don't have to be open the whole device and changing the batteries. That was something that we had in our last device that we are also taking into consideration, reducing the need for us to, or for the user or for the developer to have to open it, because this is the design is very sensitive and it has to be under certain conditions in order to be deployed. So if you have every 2 days or maybe every month or so to have to be opening it for stuff, then that's also a drawback in the design. So that's one of the benefits. You have easy access to recharge the battery, and not having to open it. Also, it has certain, of course, the drawback in the design would be that, of course, adding an additional module that would be the charging system increases slightly the cost, not much, and increases slightly the complexity of the design, of course, like adding any module. But we think that the decrease in price for the longer use and the friendliness of being able to recharge it is going to be worth it.
So I would assume it's a LiPo battery. And how would you charge it? With a USB connection that is going to be sealed, or how do you plan for that?
Yeah, exactly. Like you mentioned, that's our idea right now. The thing that we have to really look into is how to seal it. Right now in our plans, we have, like you mentioned, an USB connection. So you have the buoy. If you have some type of sealing that is easy to remove, you remove it and you charge it. And you charge it maybe with an USB-C or some type of universal easy to access connector. Now, the thing is how to seal it and how to, because you will need some type of access to the connector. So that's something that we're looking into. There are also alternatives to have like connection. There's some right now there's wireless charging. That is something that you can include into a design, but also we don't have it as our primary goals for this period, because that is a design that we will have to be more familiarized with, and it will require more time to implement it. But right now, it's like you said, with an USB port.
Got it. Thank you.
Oh, okay, great. So I just wanted to build on Clarissa's great question a little bit, and also like ask a question back to Ed. So or sorry, Dr. Triple. So based off of like that thought process of like, using Kickstarter or crowdfunding to send a whole bunch of these, hopefully, ropeless skiers out all over the world, what is that like from your perspective, like working in the government when all of a sudden there may be pop-up buoys all over the place? Like, what do you see from that that would be maybe not such a good taste to the government, or might be, I guess what I'm trying to say is like, what would be annoying or make you angry about that from your role?
You asking me first to reply? I think
Yes.
I think I can't represent the government's perspective on that, but from just in terms of regulatory framework, presently, in order to fish, you need to have a marked surface buoy on each vertical line. So in order to move forward right now, any ropeless skier that is being trialed in Canada is based on scientific permits. So the fisher would have to assess the merits of your approach and how it fits with current government perspectives on ropeless fishing, and then the scientific permit application is sent into a regional office, and then it's viewed by a number of different individuals representing different sectors of the department, and then the scientific license is then agreed upon under certain fishing terms, locations, and so on and so forth. So I think a wide use without a scientific permit would be considered illegal fishing. So it would be difficult to just populate the whole Atlantic Canada with buoyless fishing, because it would be illegal fishing without a scientific permit.
Okay, this is good to know. We don't want to promote illegal fishing. So yes, thank you for that.
Yeah, on that point, it might be good to talk to a few of the fisheries that you're thinking of testing in and see how they respond, because it may actually slow down the adoption of the technology because people are reticent to take on any risks. Like the fisheries themselves might be worried about repercussions. Yeah, so.
All right, I'm going to jump in with just one of the questions from the audience, and then I think we'll need to wrap it up shortly. So one of our audience members asked, what is the range of the buoy? I believe you guys talked about depth, but maybe this is referring more to the distance to stay in touch with the gateway and whatnot.
I could go. I mean, there's a normal frequency range for LoRa communication with good antenna. So you could go starting with 10-kilometer range to like 30-kilometer range. But before you kind of move that far, put your onboard gateway very close to your buoy to kind of put the time before you now deploy it. And of course, you can still communicate to the buoy in like that ranges of 10 to 30. So, but realistically speaking, you don't want to be far away from the buoy when setting the time. So, yeah.
Great, thanks, Toby. And one other question we had was, have you considered the potential for poaching from nefarious fishing operations, hacking the buoy location information?
Well, I would say, yeah, of course, having a server where you store information is always make you susceptible to hacking. And I mean, I have seen it in other projects where you have databases and you have some type of connectivity. You have some type of server-based connectivity. So it is not, I would say it's not something that is something that we're looking into right now to solve or to approach right now. But of course, it would be something that is inevitable when you are implementing a server side. So right now, most of the things that we're mentioning of the timer-based design, we don't need a server. We don't need a server, but we will we are considering to use it because that's why we can landmark the position, and you can create a landmark of the place where you located the buoy, and also other users, if they are deploying their own devices close to you, they don't want to have all the buoys and all the devices stack up one over the other. So we will require some type of information about if you have other buoys and other devices near you when you are deploying for different users. So of course that will require some server and database. And when implementing that, of course, we will require to make some type of protection, because not only this is susceptible to hacking, any type of server you have live is susceptible to hacking, and that's part of the main deployment for that type of service.
Of course, thanks, Leo. So I think we're going to need to wrap it up shortly. I want to be respectful of everyone's time, but thank you so much for the discussion. I think that we're definitely at a very crucial sort of turning point as far as what steps to take to get this project to the next level and get this user testing and functionality testing accomplished in the most effective and it sounds like, community-driven way, but also, of course, respecting all the local regulations and things around these bodies of water. So lots of challenges for the EJA team, but luckily we have our team here, as well as our partners and the broader open source community to help tackle these. So none of us need to feel alone in these challenges, which is one of my favorite parts of being part of this kind of community. Again, thank you to our guests, Clarissa and Dr. Triple, for your feedback and questions. And of course, to the EJA team, Toby, Leo, and Aaron. I'm excited to continue the conversation offline and figure out, what partnerships and which next steps make the most sense moving forward. And I think there might be some opportunities maybe to do some of these things in parallel or in tandem. Maybe there's some ways that we can crowdsource, feedback from the open source community on some of the more technical functionality, hardware testing that isn't reliant on being in the water. And then we can also get some of this user feedback from some of the fishers or fishery partners that we can engage with. So excited for continued discussions. And again, if anyone wants to get in touch with our team, feel free to reach out on hackaday.io. You can find EJA's team page under Dream Team on our Hackaday Prize contest page. You can also just Google Team EJA and I'm sure they'll pop up. And stay tuned for future events and contest updates through all of our social channels. You can find us at Hackaday or Supply Frame Design Lab on Twitter, Instagram, YouTube, Facebook, and Eventbrite. So looking forward to continuing the discussion, and thank you all again. And of course, thank you to our sponsors, Supply Frame and DigiKey, for continuing to support open source hardware and make these initiatives possible.